Right, so 7.3 deals with logarithmic functions. So a logarithmic function looks like this. We have log base b of x is equal to y. So that's how we would read this. Log base b of x is equal to y. It can be written in the logarithmic form. So this is log form. Or it can be written in exponential form, which we were just dealing with exponential equations before. So this is exponential form. And we can change something that's in exponential form and put it into log form, and we can do the same thing vice versa. We can change it from log form and put it into exponential form. So one way we can think about this when moving it, I guess you could say, is we have the base, which is this b, raised to the exponent, and is equal to the answer. Now when putting this into log form, we're always going to start, log form always starts with the word log. Then we put the base into the basement, and then we're going to write the answer, because you could think about it this way. So base goes in basement, the answer, so answer starts with A, goes next to the base, B, so A is next to B. Then we have the equal sign, and then the exponent. So always you're going to have the equal sign and the exponent. Just think E is next to E. Equals is next to the exponent. So this is just one way you can think about it. You can look at it whichever way you want to. But it always has to go from this form to this one. And then we can go back from the log form to the exponential form. So let's do some examples now. So we need to write each in logarithmic form. So in log form, we're always going to start with the word log. Then we're going to put our base into the basement. Then next, we're going to write our answer, because A goes next to B. So our answer is 243. And then we put our equals, and then the exponent, which is 5. Now we're going to do the same thing for the next one. Log form always starts with the word log. Then we put our base into the basement. Then we write our answer, because A goes next to B, then equals the exponent. We write log first, then our base goes into the basement, then we write our answer, and then equals the exponent. Next one, we do the same thing, log, our base goes into the basement. We write the answer, because A goes next to B, and then equals the exponent. And then our last one, we write the word log, because log form always starts with the word log. Then our base goes into the basement. Then we write our answer, which is C, so answer, and then equals the exponent, B. Any questions on changing it from exponential form to log form? All right, now we're going to change it from log to exponential. So here, we're going to look, we know that our base is in the basement. So we're going to start with our base, which is 9. Then our exponent is on the other side of the equal sign. So we write our 1, that's our exponent, and then we're left off with just the other 9. The next one, our base, we get from the basement. Our exponent is on the other side of the equal sign, and then we're just left with the remaining number, which is 512. The next one, we get our base from the basement. Then we get our exponent on the other side of the equal sign, which is 1/3. And then that's going to be equal to whatever's left, which is 2. Next, we get our base from the basement, which is 4. Our exponent is on the other side of the equal sign, -2. And that's equal to whatever's left, which is 1/16. And then our last one, we get our base from the basement. Our exponent is on the other side of the equal sign, and then that's equal to whatever's left, which is just 1. So one way to check to make sure you guys did all of these right is the equations are always going to make sense. So if we look at the first one, 9 raised to the 1 is 9. If we wrote this any other way, let's say you did 9 raised to the 9, that's going to be some absurdly large number, and it's not going to be 1. So you know it has to always be 9 raised to the 1 is equal to 9. So all of these equations are going to make sense. So this is from logarithmic form to exponential form. Any questions on this part? All right, last slide. So now we're going to evaluate each logarithm. So first we're going to look at log base 2 of 16. So this is going to be equal to some number, which we can call it x. So the best way when doing these is to change it from log form to exponential form, because we can solve an exponential equation. So our base we can find in the basement, so we have 2. It's raised to, so our exponent is going to be on the other side of the equal sign, and then that's equal to whatever's left, which is 16. So we need to find out 2 raised to what power is 16. We can do that on the side over here. So let's say 2 times 2 we know is 4. 2 times 2 times 2 would be 8. 2 times 2 times 2 times 2 would be 16. So we have 4 2's here, so 2 raised to the 4th power is equal to 16. So our answer to this would be x is equal to 4. So this is our answer, just 4. Let's look at our next example. So this is going to be equal to x, because that's what we're trying to find. We're trying to find what log base 8 of 8 is. So we're going to get our base from the basement. Our exponent is going to be on the other side of the equals, and then that's equal to whatever is left, which is 8. So 8 raised to what power is 8? We know that this would mean that x has to equal 1, because x raised to the power of 1 is 8. Any questions on these two? All right, 2 more. So here we have log base 49 of 7. So our base comes from the basement. Our exponent is on the other side of the equal sign, and that's going to be equal to whatever's left. So we need to find what power of 49 gives us 7. So we know that 49 to the power of 1 is 49. 49 to the power of 2 is even bigger. It would be 49 times 49, which is a large number. But we're looking for a small number. So what we can do is try fractions as our exponent. So we could try 49 to the 1/2. And we know 49 to the 1/2 would be 7. Because taking 49 to the 1/2 would just be like saying the square root of 49. And we know the square root of 49 is 7. So our x is going to be equal to 1/2. Any questions on this one? All right, last problem. So we have log base 2 of 2 raised to the 5. So we need to find out what this is going to be equal to. We're going to get our base from our basement again. Our exponent is on the other side of the equal sign. And that's going to be equal to whatever's left, which is 2 raised to the 5. If we have an equation where we have the same base is equal to the same base, so 2 raised to the x is equal to 2 raised to the 5, we can get rid of those bases and just say that x is equal to 5. We know our exponents, this part here, is going to be equal to this part here. So x is equal to 5. Any questions?
Miss Carter?
Yes.
What is that? Like, what if it was like a 3x equals 2 to the 5th? Would it still be the same?
No, you can only do it this way if you have the same bases. So let's say
We just get different ones.
if we had different ones, we would have to do something else to solve it. But don't worry about that now.
Alright, thank you.
Alright guys, so remember the notes are due by 2:30 today. So make sure you turn in your completed notes. Any other questions? Alright, bye guys, have a great day.